So, that's not actually the title of my talk, but that's my start. Welcome to Perl 11. That's something we came up lately, inspired by this lady here. You started it. No, it was, I think everybody thought about it. We are not so happy with Perl 6. First with the syntax, and then with the performance, and backwards compatibility. And what we really want to have is keep on doing our Perl 5 stuff, and then gradually take in Perl 6 features. And Perl 11 is the simple idea, 5 plus 6 is 11. And P2 is just 1 and 1 is 2. And there's the website Perl11.org, so there is Perl 5, Perl 6, Perl 7, Perl 8, Perl 11. Pretty easy. But it started here in the German town called Perl, where Liz and Randy invited some Perl 5 and 6 developers to a reunification summit. Bring them together. That's my input device. It's fabulous. So you see Patrick Michaud and Jonathan and MSD and Riva Sushi and Leon and Liz. There are not so many P5 hackers, unfortunately.
You have to speak into the microphone so the people online can hear you, Reini.
So not possible?
Too bad for them.
Yes. Let me see. Because now I have to do two things together. Three. Talk into the microphone, fix my pointing device, and do the talk. Not too many P5P people were there. I think only three committers. MST, Leon, and Reini. But all the Perl 6 people. And naturally, okay, something came out. Larry agreed to do the standard 5 grammar. I think he already started before. Larry, did you already start it before? But at least, yeah. But at least I think at the end of the summit he got 50% working. So that's one we wanted to have one Perl 5 on Perl 6, but not with blitz costs, but using a different parser, but using. But then, how do I do it then? Using a separate parser just to parse Perl 5, but running on the same VM because you want to use the same data. Just want to use different, better control structures. In here, with this one? Oh, the same as mine. Good. Let's see. It's not so important. I can stand here also so you hear me better and then walk around. What's the next? Oh. Yeah. And they paid for everything, which was the best. So a lot of people came. So you see, with Perl you even can make money, be successful, and invite other people. Oh, I think I give up on this one. Okay. What do we want to talk? Yeah, okay. Reunification Summit. So we want to use the same data, but with different programs. Use different syntax, combined syntax. But it's not so easy to combine a GC with ref counting, for example. And different strategies, or use it a non-threaded Perl with threaded Perl 6 and so on. So it's not so easy, but we still have the idea it should be possible. And why do we want it? Because we want a faster Perl 5 and we want Perl with more features like Perl 6 or maybe even more. So after the conference we went up to the Preikestolen this hard way to fix up the P5 mob. With Stefan Little. Maybe I got a pointer here. Yeah, Stefan Little. He got pretty frustrated with P5, the P5 mob integration, but it was mostly technical points because his mob mainly needed anonymous stashes. to store objects like prototypes, like this. And it was super slow. So it was a hard way, very easy to hurt yourself on these stones. It was, I think, 3 hours. And it's a crazy stone up here, and it's very easy to fall down. I didn't go there. I stepped back about 200 meters before. I was the only one, because I was so afraid of hate and so on. And my wife stepped someone over here, and then it just broke over to me, and then I couldn't walk any further, and I just walked back. These are the forks on the stone. And then afterwards, I think that was the time when Stefan Little decided there's no way out. Because, no, something before. That's the birth of Perl 11, those guys. Because we got the bid for Austin Yapsey, that's here. And here was the president, where is he sitting? With the hat. Here it is. So his idea for this Yapsey, for the model, was optimizing Perl, or fast Perl, and then he invited Ingi, not here, and me, and some others online to talk about how to make it faster, how to make it fun, to write optimizers in the sense of audio tank, or optimizing for fun, how to bring, is Perl 6 the future or Perl 5 the future, and so on, how to attack it, what's the problem with P5P, why don't do they accept more radical changes, to make it faster, why doesn't Perl 6 get faster, and so on and so on. And we, of course, couldn't solve these problems because we are different guys. But we came up with the ideas of better integration. So that basically was Will, Ingi, me, Flavio Clark, because he has already source translators, and it's with his translators, and he has a super nice parser. With Perlito, that's a handwritten parser. To run on fast backends, optimizing for fun. And I came up, or I think Will and me came up with the idea for the optimizing compiler PCC to do more optimizations in it. But then on January, Stefan Little announced, here's something to say important, that he will abandon P5 mob, which got a lot of people angry. And on the Breakstone, I decided that PARROT is no future. Of the Perl 6 guys told me it looks super bad. We've got only 2 developers, that's me and White Knight. And White Knight got a burnout. I got pretty angry that about management decisions, and I didn't think that the slow calling convention could be fixed in PARROT. Or maybe if it would be fixed, maybe someone else would destroy it again, because it was fast before. I think Dan had a benchmark where PARROT ran pretty fast, at least faster than the JVM before. And then it was de-optimized several meetings afterwards. A lot to talk about this, but anyway, Perl is a dead end. What he meant is P5 mob is a dead end, or maybe Perl is a dead end. And came up with this one, just to take a different VM, which already exists, Scala, and use a Pax-like approach. So that's basically Pax in Scala, and the name was Mo. And I decided I won't use VMKit, which was my idea to replace PARROT, and I'm using Potion, which was a crazy little VM nobody uses because it was not ever released and nobody knew about it. And some other guy in parallel, François Perrat, who was a major PARROT hacker, came up with the LuaJIT idea I had no idea about. And apparently the Perl 6 guys came up with the idea to replace PARROT by their own PARROT-like approach for a 6 PARROT, which they called then MOA VM, but I didn't know about. But which had threads inside already. So this is what I wanted to avoid. And I rather wanted something like this. So I wanted new, fancy, small, flashy, or maybe even something like this, maybe for the beginning. But it should look like this. So small and fast and nice and sexy. So I came up with this. That's a P, and that's a 2, I think. Oh, different? No, that's a P and that's a 2. Which was actually the mascot of the Potion VM. It was a crane, but I thought a pink flamingo is better. And the color fitted very nicely to this one. So that's my little mascot. Oh. Maybe show it. Currently it looks more like this one. So it's a race engine with a very small engine. Very small, very nice, but hardly usable. Still in early development. Do you know those cars? They are crazy cars. They are the jumping cars. The Mexican folks in San Antonio use it mainly so they can jump around. They even made movies about it. I forgot the name of it. It doesn't keep. That's the hardest part of the talk, okay. To keep it sane. So this VM came out, I just found by accident because I didn't know this guy, but now let's talk about the guy later. What we wanted to have is features. Basically, Damien Conway already had designed this, but deleted the webpage later when the Perl 6 design went official. But it was a design how to improve Perl 5, Perl 5i. You know it from Schwern. It's basically, he said, classes should be immutable. So we take a new keyword class and make them immutable because then you can optimize method calls because you can't add methods at runtime. And if you can't add methods at runtime, you can index it and have much faster method lookup, or you can even inline it. So it's some simple language performance issues which were never really implemented because it's not so easy. Because you would have to destroy everything. That's why he took new keywords like class and method instead of package and sub. And with these new keywords, he was able to do the semantics. But unfortunately, nobody ever implemented it yet. But it's just a little bit. He also added attributes and a lot of crafty stuff. You can look it up. I have a link on the P2 website. Performance. I work at cPanel. We are not so happy with Perl 5 performance, even if it's much faster than Perl 6 and most of the other stuff, or Python or Ruby. But so we compile it. We mainly compile it so it's a little bit faster. Startup time is about 10 times faster. Destroy time is 10 times faster. Runtime, not really. It's only because we remove all the stashes we don't need, because stashes are only needed at pass time. And we're trying a little bit optimizations on it, but not 10 times faster, maybe 2 times faster or so. I came up with little optimizing approaches to make it 10 times faster. With YVM, I'm thinking more about 100 times faster or so. We want threads. So if there are CPUs available, they should be used. That should be easy. A little bit more of sanity and a better future. Sanity is more management problems and the code craft, and I'm going more into aesthetic issues then. And the idea was how to do that. We have 3 parts. Do you hear that, the microphone? We have 3 main parts, the parser, the compiler, and the VM. And we want to experiment with all 3 of them. So like in pre-Parrot times, we wanted to step back because Parrot for us was not really the good thing anymore. So what kind of parsers can we use? Do we have to write a handwritten parser? Do we have to get on with the Yak parser, or the Bison parser from the old one from Larry? Or do we use the new Perl 6 parser, which is kind of runtime? You can execute grammars and compile grammars at runtime. Or do we do it at compile time? The compiler, which is basically a little transformation from the AST, from a tree to the operation, to the ops, and then the VM, which execute the ops, and then the libraries, which we need behind the VM. But libraries is not the hard point. The hard point is the parser, compiler, and the VM. For the parser, we've looked at Yak, because that's pretty much the best parser you have, or the parser generating engine. It's bottom up, so you go from the little thing to the big thing on here. That's the natural way to parse, but I don't like it that much, so I choose PAC. Oh, it was chosen for me because intentionally the other guy had the same idea as me, but I would have chosen the same. That's a PAC-RET parser. The PAC is a parser expression grammar, which is basically creates a state engine which runs the parsed actions at runtime. Can you say it like this? Yeah. It's a very expressive syntax, and you can express your grammar top down. So you have predictable order of rules. Yeah.
Would it be accurate to say, to describe it to the audience, it's kind of like parse rect descent?
Nope. No. A little bit simpler. Parse rect descent is runtime, and this creates a C file. The style is parse rect descent.
It's a similar expressiveness, but
expressiveness is similar, but it's more beautiful. I'll show it later. Much more beautiful. The style is similar, so it's top down, not bottom up. It has memorization. There are two styles, lexical or PAC, and I'm using the predictable one.
Microphone.
Yeah, microphone. But there are also other parsers, so I'm not bought into PAC yet, because I think I will run into problems later with expressions or ops. People have Java and C grammars, and I think I can solve the problems with prototypes, which is runtime binding or expansion of methods, which arguments to take next or so, and begin blocks, end blocks. It's not that hard to parse. The hardest is indirect method syntax. I'm struggling with this for a few weeks now. But the Mapper guy said that should be easy, but I don't like his code. The Java guy said Antler, hop, why using something else? But I don't like it that much. PGE, that's a nice one. That's something I want to have, because that's the Perl 6 grammar engine, and they do it at runtime. I want to have a parsing engine where you can add grammars or rules at runtime. That's basically something like Parsec does. Parsec is the Haskell library where you can add rules later. It's a combination library. And so there were different approaches like Maru, which is a little Lisp engine which cheats a parser, where you can easily add rules later. And I only wanted this for macros. And the best thing is usually handwritten parsers. That's what I found out. So Perlito, for example, has a handwritten parser. It looks so simple. Or Go, Rob Pike wrote his own little parser. It looks so simple, so small. I want to have it small and simple and understandable. And with Yak you need a lexer. With this you don't need a lexer. With Mapper it's optional. With this one, PG, Parsec, that's a little bit too much for me. But I'm not sure yet. The compiler, it's mainly about data structures. So you transform this little tree to ops, and then you have to think about the performance. The compiler actually in Potion is 1 page long, about maybe 150 lines or so. It's a little transformation, so it doesn't do that much optimization, but it's easy to add. So I think there's only constant folding for if. There's not much other optimizations yet because it's so fast, but I can add it later. Mainly inlining. It should output, it should be pluggable, so I want to have different compilers. I want to emit to the VM, to a JIT, which is already done, to BC, that's bytecode, that's the serialization format everyone wants and needs, that's PLC files or PMC files, but also to C and native code, because native code compilation is not so hard. We have the JIT works, it's just adding the symbols, the data tables, and then link it together. So writing a linker is also not so hard. Or the JVM and JS, but not me, someone else. So the compiler should be pluggable. I think it already is pluggable, just the hierarchy, the object system is not yet there because I don't have method combinations yet. And then the VM, the third part, what we want to have pluggable is to execute the compiled code, which is basically the bytecode, the simple engine, which is a switch statement or something like this, or computed go-to. The JIT, which is super easy, and also libs, libraries. And the most important thing is not to reinvent everything. So the calling convention should be native C. So we use a stack or registers on 64-bit. And it should be natural to call in and call out. So the design principles, and that's now the starting of my talk.
That's the start of your talk?
That's the start of the talk. Before was history. Before was about 20% of the history. Optimize for the frequent cases. And don't optimize for creating new methods or creating new classes. Deep scoping situations where you have to look up lexical variables in 2 scopes upwards, which would be nice to have and which Perl 5 has because the compiler aligns it differently. But to do it efficiently, I want to have it on a C stack. And it's pretty hard to jump over to C stack because then you need to know the size of the previous code segments and all these jumps. So if you look at compiler handbooks, this is pretty hard. So I just jump up my closures to the previous stack. And so lexical variables are on the stack, on the C stack. Changing the but that's little bit slow. But most of the Lisp compilers I know, I come from functional programming, they do it like this. With Perl 5, it's a little bit easier. Change the inheritance tree. That's the hardest part. That's what I want to avoid. That's one of the main reasons why writing my own project is to have const either and const classes, so I can optimize method calls. Eval is not so slow. Okay, you will see it's super fast, but it should be much slower than this one. And code allocation. I didn't even write this. That's why I did it. But the frequent case is mathematics. So you have a natural expression of integers or floating points and do arithmetic with it and JIT nice and easy with it. I have a little bit of different opinions with the other VMs like Dart or V8 on the optimization. So I favor they favor math even more than dispatch or just basic point object access. So they favor the data layout that integers are native and pointers need to be shifted. And I favor pointed, so I can directly access any subpointers and do a little bit of shifting. It's just assembly with the math. Conditional should be fast. Function calls should be fast. They're super fast. They could be even faster than C because there are a little bit of optimization to an assembler and some stack inlining and call CC and yield comes up to doesn't reuse the stack, so it's basically like a stackless Python, unladen swallow, I think was the name. So you don't have to reuse the stack. That's an assembly hackery, but that's pretty fast. Method dispatch is cheated and super fast. Local variables, okay, that's not local in your sense, that's lexical. I don't have dynamic variables and local variables yet, but it's pretty easy to implement, and I already started in a branch, but so far I only support lexicals and globals, which are in a global environment. Strings, that's the hardest part. So with strings, Y decided to make strings immutable and have buffers instead, if you want to deal with I/O. So little string comparison are O1, we just compared integer. But doing slices and so on is creating garbage. Or subslices, substrings, it's creating garbage. But you can decide on the language level, on the Perl level, it's basically creating a lot of string garbage, which is recycled in the generational collector. But if you write an extension, you can use buffers. It's basically for I/O. Network files and so on. They are using buffers, or the parser using buffers. And memory allocation is pretty fast, so it's using a GC and not ref counting. because, yeah, anyway. So for the efficiency I want to have is something better than JVM and CLR and LLVM, because here we have overhead. LLVM is mainly size overhead I don't like.
Could you say that one more time?
I don't like the size overhead of LLVM. I don't accept the fact that I need to have 30 megabyte of a library just to do the JIT when I have a 2-page jitter. And so I don't have all the optimizations they do. But it's pretty easy in the 2-page compiler to do the optimizations also. So I rather go for easy access for this little thing here, and not the reinventing the wheel. Be a loner. But JVM, CLR, LLVM, it's good, but not for me. Rather go this. ML, Lisp, Lua, Go, Smalltalk, Viet, they are the fast VMs. And I looked at the VM design they are using, or there's a famous talk about Ertl, but the ex-professor of Leo Tötsch, the Parrot designer, or one of the Parrot developers, and not doing it like smaller, slower VMs, which is basically, I hope it's on the next slide. Yeah. It's basically, don't use LLVM just for a JIT when it's easier. The Lua JIT guys actually have a nice little library, which the Chinese guy is using. Is he here? No. He came up in the lightning talk yesterday about sregex. That's something I wanted to have also. That is cool. And I'm so glad he wrote it, because I wanted to write it. I was super sure I'm going to write this. And he's using the Lua JIT dyn Essen, which is interleaving his logic with little assembler statements. So he has a combined VM with the JIT, and it's super easy to express. He has a little Lua program, or he didn't write it, Mike Perl, the Lua JIT developer, wrote it. So he has already support for all the CPUs, from MIPS, Spark, Intel, PowerPC, ARM, for a JITted regular expression engine. Because eventually we don't only need the VM to be JITted, we need the regular expression engine to be JITted, and we need the parser to be JITted. That's the goal. I don't like JVM, once again. For the startup overhead. It's nice to have it on this little thing here. That's one of the goals. Little devices. But
what is the disk VM?
Okay, that's the disk VM. So ideas have been invented in the 70s, 80s. And when Sun came out with the ideas for Java, Lucent already had their own VM, which was a much better idea for their kind of Java, but they wanted to have with Smalltalk. So it didn't win. And Java guys came from Lisp, and they said, we do a Lisp, but strip it down and use C-like syntax, Algol. But that's basically Wapike and the Go guys. Or Lucent guys, so the Inferno OS and Limbo. So the disk VM is basically kind of Parrot, so it's a register-based VM with very efficient design. More efficient than Java, but it didn't win. So you see verse is better. And yeah, but in little languages they use it. So Lua uses this design here, which is basically GC. Java uses a GC. Register-based 3-address coding. GCC uses 3-address coding, SSA they call it. In this case, it's every op only takes 2 arguments. Every op is 1 word only. Word size ops. So every op is tagged into the op type. First argument, second argument. Second argument is optional. Every op argument is indexed to a register on the stack. The compiler does this little SSA transformation. So the compiler, if a method or a function or an op needs more than 3 arguments, split it up. The data should be super small. So with Perl we use bigger data, because then we have faster access, and their approach is to use slim data, because it needs, we prefer cache line access over fast access on the heap somewhere. So the data needs to fit on the heap. Falk could say much more about his Falk 88. But the basic idea is give up a little bit on more efficient data structures, make it more tightened, but then win in the execution time. Of course, this doesn't scale, but that's the idea. PARROT did most of it right in the beginning. So you got pluggable syntax, got pluggable types, got pluggable ops. That's why MOA also uses it. Pluggable syntax, they even extended it to have runtime syntax. So you can add grammars at runtime, and I don't have it yet. I'm only thinking of pre-compiling grammars and loading it via shared objects.
What
Do
about
that.
dynamically loaded opcodes?
Nope, don't need it. I have the mob.
That's what plug. That's plug.
I have methods. You can easily load any method. You can easily load classes. But why do we need 400 ops? I think about 7 ops. I came up, so a normal Lisp machine has 7 ops. Then eventually more like 30 or so.
M0 has 37.
Yeah, 37, something like this. And Lua came up with 50, and Potion is just taking the Lua design. And added classes, so you don't have objects, you also have direct access to the type of the object. And maybe a little bit later. So pluggable syntax means you need a common AST. You have to use the same AST because the compiler and the compiler could use some specialization on that kind of data if you want to pass JVM, but it's better to have a common AST and don't use world like access in P6 where you express everything in the data. I want to express everything in the syntax tree. So the syntax tree is pretty messy. So I have the type declaration, I have constness, and everything is in the syntax tree. So the compiler and the VMs can then do their optimizations on it. The types.
Is there any kind of spec on the AST or no?
No. I'm fighting currently with the AST. I have a working implementation Potion, which works super fine, which is nice, which is stable, and which will soon be released when I fix the GC bug I found out when testing it for the release. And then I map just the Perl 5 and then the Perl 6 and later on all the other syntaxes I want to support. I want to support SQL, C, Java and so on. And then I map it just onto this AST. And it's basically Gimple syntax or Lisp syntax. A tree with a lot of parentheses. I'm sure you will see it. The types, it's basically type system is not so easy. Chip can tell you about it. So basically you need runtime loadable C++ objects, which is not doable because every C++ API is not defined. So Microsoft and GNU and Clang, they have different C++ object layouts. So you need some tricks to get to this.
Well, unless you're willing to just use the same compiler for all the pieces.
Yeah, with the same compiler it's doable. We did it, and the Topaz idea is extending on this, the types, yeah, the vtable.
This is the two talk.
Yeah, but the pluggable type system, so that's solved and also supported with Potion, and pluggable ops. That's kind of I don't need ops because every ops has to be cheated. I don't need to cheat every op. That's what my main critic on PARROT is. If you don't want to write a cheat for it, just call it. So put the arguments on the stack, do the call, which is I think E9 and the word size of the pointer, and that's it, and get the result. So you don't need to cheat a common function call, like what's in physics bind, or any method which exists in the C library. GetPit, yeah, forget getPit. I mean, like really usable function ops, like method named or class or so on. Anyway, or find lexical, or find name, or all this lookup stuff which should be done on the C level. So, PARROT was once fast. Did I already say it? Yeah. Then had some benchmarks. Then it was, in my point of view, de-optimized in several steps over time, in several flows it came in. One of the first flows I got out in 1.0 and then came back and then was not optimized, de-orientated or disencouraged to work on it again, and I feel very I feel for Perl 6 because PARROT was pretty a mess. The threads implementation of PARROT is actually one of the best I know, but the P6 guys don't understand it. And they had a little bug in the lexical, in their own wrapper for to access lexical variables, which broke everything. And it's not so easy to understand because I didn't understand it either. And they came up with their own threads in more, which is completely different. But our system is safe, but I'm not sure if it scales, because if I want to change a variable, I have to do it in the owner thread. So the owner thread creates a little subthread, which is a thread with highly prioritized in the scheduler, which is then able to change a value. So that's super safe because you don't have shared memory. And you have a lot of callbacks, and the callback should be created automatically. So if you write a setter method, it needs to create a subthread which in their owner which changes the value. So you'll never run into problems, and that's what I want to use. And I'm still thinking of the design of my threading model, but I don't want to have unsafe shared memory. I either want to go the Go variable where I have even typed channels to communicate with threads, or the simple way which PARROT had, but the PARROT threading model is not really over-designed yet because nobody's using it yet. And then suicidal tendencies.
You want to explain that a little?
Nope.
To everybody?
No.
But is that your feeling? What are you talking about?
It's like, for example, you remove the JIT and...
I did remove the JIT, and
Yeah.
that was like the first time I was release manager. You know what?
Yeah.
The entire community asked me to do it. So
Yeah, I know. I said no.
I know you said no.
And I felt the arguments were not right, but I couldn't express myself.
Is it a good thing that this isn't on the microphone?
It's on a microphone. No, it's not leader. It's more like other guys, and people would know what it mean. But it's basically it came in flows, and then the manager came up, and then we'll embrace Perl 6 again, and then they want to get rid of our FFI because the Perl 6 guys do not use our FFI; they're using their FFI, and so on. But if you want to be a library, we have to have an FFI because without FFI you are lost, and so on and so on. But mostly it's the calling convention. For example, we are calling a method via the FFI, and we're passing the signature at runtime. We have a string where we pass the signature, and of the type of the signature we have to dispatch. But it's a string at runtime. That's super stupid. Nobody would do it. Okay, we're coming to suicide. This guy. So that's Jonathan Gillette from Provo, Utah. That's south of Salt Lake City. I've been there. So he's married, has a kid, but apparently got some problems. I think he has problems with the Ruby community, but he's a pretty eclectic guy, which you will see soon, but he writes super nice code and super nice comics. So he wanted to have a little teaching language to show kids UI design. So he wanted to have a little language where you can represent objects, UI objects, windows, classes, and so on. And he didn't like Ruby that much. He liked it because Ruby is basically a fork of Perl, which is much slower, but a little bit different syntax with object system. But they didn't get it right, but still they won almost because a lot of people are using Ruby, even if it's much slower than Perl. And even if they have crazy web frameworks, there's even a conference here in Austin, the South by Southwest. It's only a Ruby conference where how's the Ruby framework called? Everybody, Rails.
Ruby on Rocks.
Rails, okay. Crazy. Anyway, so he got angry and wrote his own VM, which is a super VM. So he took the Lua VM, he took this guy's IO object model, which is kind of a little mob, which is Smalltalk based. And so this guy is Ian Pumata, which is basically a good friend of the Smalltalk inventor. I think he's from Britain, and more like a functional language Lisp guy. But so he wrote the parser and he wrote the object model. and he's working on a project F-Func, functional object. So he wants to recreate the power of small talk in the world, so show everybody how good small talk is. He wanted to show how good Ruby is, and we want to show how good Perl is. He uses a crazy, super modern GC, which is a chainy two-finger loop GC from Kish. He took most of the stuff from French hackers, he said. So that's a French GC, but it's also used, for example, in the Lisp I'm using in C Lisp. And the JIT he wrote by his own. So Potion, it's using a common number interface, which is a little bit different to Ruby. So he came up with designs which went from Ruby more to Perl back. Or let's say Ruby. Let's say Lua. So he decided to take the Lua engine, and Lua is a little bit crazy because Lua has tagged numbers, so you have to shift off an integer, and it's automatically Lua is automatically calculating in floats, and it's not doing overflow detection. So it's exacting integers, but does everything on floats, which is a little bit crazy, but apparently it's fast enough, because Lua is one of the fastest scripting languages. Potion doesn't do it like this. Potion is like Perl. It has a common interface, so we have NV and IV, but we use it as one, because we don't care. That's done automatically at runtime. Here also, it's the num class, which is basically taking the integer part or the floating part. And you can easily add big nums to it without the user seeing it. I'm not sure yet if I should do it, if I should use the Pragma use big num. I have it already in the library, but...
I'd say if JITting has taught us anything, it's that deferring a decision like that till runtime, rather than asking the user to say it, works well.
Yeah, I have to hurry up. Oh, I'm not so fast. A common hash array interface. Lua does not decide between table and hashes. Arrays and hashes. Everything is an array, and if the index is a key, is a string, it's a hash, and otherwise it's an array. There are no linked lists. There are other VMs which are also using linked lists, which are also pretty easy to change. Just relink. So we have to realloc all the time, but it's still pretty fast. It's using a nice hash library. And it's a common interface, but still the methods are different, and you can easily cast. So he's not using the common hash array interface from Lua. He's changed it. It's like Perl, but it's more Lispy-like. I want to have it more functional, so I don't want to have. I want to return copies and not references. And if a library author wants to have references, then there's a different name for it, like reverse and reverse. Return a copy to be safe. Not efficient, but I'd rather prefer safety on this part. Or splice and so on. Same with strings. Substring returns a copy. Everything is an object. Every object is a word size. Every op is a word size. Potion means something like smelling good. I have no idea, but it's super small, very easy, and that's P2. That's the crane or the flamingo. That's the guy. I want to show a short video.
That was one of my Ruby goals, was eventually meet this guy who wrote this great book that motivated me to learn more about Ruby.
It's only 1 minute.
Who's why? What's why?
Why the Lucky Stiff is an enigma, yeah. The guy was totally, instrumental, very creative.
He always struck me as somebody who just got the programming as art.
Huge person to do just code bombs. Here, boom, this is a solution for this.
Well, what happened? He disappeared. It was deliberate on his part. I'm certain of it.
All of his stuff is just gone.
It's like a mirage. He came and he went. I just hope he's okay.
If somebody's going to ask who's why, what's why, I'd say probably Al Picasso.
That was really his gift, was taking programming to the masses.
I like the syntax actually a lot for me.
I would say one thing that I've spent the last, since December, porting about 5,000 lines of Perl to Ruby, and at every level it's just a little bit better than Perl. And it would be the first, for a new project, everything being equal.
I definitely this code just went
Yeah, on the language level, but on the VM level not.
Yes,
yeah.
I agree.
But I'm so super happy. I was a little bit angry at the beginning of this conference, but with Larry's talk where he said that actually we will get optionally Sigil-less language, which looks more like JavaScript or Ruby. That would be super, because I dislike all this clutter on the screen just to have the type, because everything is a scalar anyway, unless it's not a scalar. For arrays and hashes, I'm okay with having something expressing that's a scalar. But for a scalar, which could be a function or anything, so if I call a function, it's just a or just a name, or it's a variable, that's easy, but it's not backwards compatible, of course. So a little bit of parsing, but then I have to stop. The syntax tree. So if is an expression, because it should be a functional language, everything would return something. So it could be an assignment on the right-hand side. Here are 3 errors. Maybe you find it. But it's not so important.
Is there a prize?
No. I only found first at 1 at the beginning, but then later on I found 2 more. But okay, there are 2 options for if. The simple case is the AND case, and the complicated case if you have an else or else if. Else if is with a star, so PEGAX style. You group it with parents and 0 or more, and this is adding the action. So we have a combined YAC style grammar. Actions are in the code, and since you can interleave the actions with the rules, within the rules, it's super easy to express yourself. And this is completely wrong. This is totally fucked up. The first line is okay, but this should be the return value, which is $YY or $$ with the normal parser, and it's using normal parser rules. This is completely wrong, this is completely wrong, this is completely wrong. This is bullshit. Actually, it's... But actually it works because it's returning this one, and why? That's the third error. Because if actually is an expression, and if is passed as function, not as statement. So it's never executing these rules. But it would be the same layout. So if is... There are no function calls, there are only method calls. And method is sending a message to an object, Smalltalk. Thread safety. And this is super fast. It goes down to function calls internally, but externally. So we have if works on a list of an expression. This is a constant, so it can be constant folded, and this is a block. So we have if is a function, because list, a function call is something with a list and then something. And this is then actually done in the compiler. And the compiler then sees the if and these little rules, which are actually compiler macros, and serializes to these opcodes. And constant folding would be looking onto constant expressions. So everything is expressed here on the AST tree. And this is actually not yet optimized, because constant folded, this would go away. And this would go away, and this could be optimized a little bit, but all the compiler does is optimizing on this tree into this. This is the bytecode and also the JIT VM, and this is the index onto the stack, and that's actually the C stack. This is somewhere up on this C stack. That's a pretty heavy value. Those 3 are internal, so this is external. That's somewhere up. And this is the return value. Yeah. And I think I have to stop now, right?
It's 2:20.
Yeah. Maybe catch me outside, because I completely fucked up my time.